We're looking at lesson 4 as part of our sketching parabolas lessons. And we're looking at the quadratic formula. I'm using that to help us sketch parabolas. So what was the formula for the quadratic rule? There it is. X is equal to negative b on 2a plus or minus b squared, take 4ac, all on 2a. So this can help us solve quadratics. It all comes from this rule: y is equal to ax squared plus bx plus c. So this is called standard form or general form. This is what we normally put our quadratic rule in terms of. And the quadratic rule can solve or find the x-intercepts by simply plugging in a, b, and c. So if we have a look at this here, a in this case goes here and here. You've got b, which goes here and here. And then we've got c, which goes there. Oh, I missed another a and there. So those letters go into those spots there. Okay, now one other thing we have to remember is this b squared minus 4ac. It's also called the discriminant, and it can work out how many solutions there are to an equation. So sometimes we use a symbol triangle instead of saying b squared minus 4ac. And we know, like, what's the square root of plus or minus 36? You can have positive 6 or negative 6. So there's two solutions. Let's just say plus or minus 0. There's two answers, 0 and 0. Or is that just one answer? Yeah, just one answer. So there's one solution. And the last one is plus or minus, and let's say square root of 25. Now, we say that there's no real solution to this. To take a square root of a negative number like that, there's no real solution. Now, why is this important? Well, it actually tells us what each graph looks like. So I'll do a picture of this, and it's well worth putting this in the notes. If the discriminant is positive, so you can go positive, then we're expecting to see a graph that will cut through and be two separate and distinct solutions, x-intercepts. If we have the discriminant as equaling 0, then we're expecting to see this graph have a repeated solution. So it may bounce here. So it's got, or may bounce like this. So it has a repeated solution. Okay, now if we have a discriminant which is negative, less than 0, then we're expecting this to have no x-intercepts. So it might bounce like this, or it may bounce like this. Okay, now this is really important stuff when we're trying to figure out how many solutions a quadratic may have, and can save a lot of time as well if you just check this first before you move on. So with all this in mind, we're going to work on the first example. This is example 12, sketching graphs using the quadratic formula. So here we go. The question's asking you to sketch the graph of the quadratic labeling all significant points, round the x-intercepts to 2 decimal places. So what they're asking you to do here is, can you find the x-intercept, maybe we can find the turning point, and maybe we can find like a y-intercept as well. Just some key points to help us sketch this thing. So let's start off. It's saying that it does have x-intercepts, so let's just assume the discriminant is going to be positive. So let's use our quadratic rule. Now, in this case, we can see that A is 2, B is positive 4, and C is negative 3. Make sure you make that negative because it says negative 3. So let's sub in what we know. X is equal to negative B on B is 4, so this is 4 squared. A is 2, C is negative 3 on 2A. Let's simplify. Negative 4 on 4 plus or minus, and this becomes the square root of, I believe it's 40, top of my head, on 4. We can simplify this further. This becomes negative 1 plus or minus, and we can simplify this as root 4 root 10 on 4, which eventually becomes x is equal to negative 1 plus or minus root 10 on 2. Now what we're going to do is we're going to plug in this into our calculators. And just to give myself a bit more space, I'm going to go up here. And we're going to go to 2 decimal places. So we plug this in and we get an answer of 0.58. The other answer is take root 10 on 2, negative 2.58. So we've got two solutions, 0.58 and negative 2.58. Now these are essentially X-intercepts. So you can think of these as coordinates like that, okay? So we've got our X-intercepts. Maybe we can find our Y-intercept. This one's really easy because you make X is equal to 0. So we know that's going to be 0, negative 3 using our original formula. What else can we do? Well, one other thing I'd like to find is something called the turning point. And we're going to start sketching this, and I want to show you something that's pretty cool about the quadratic formula, and we'll start using that straight up after we see that pattern. So let's draw a graph. I'll go like that. Like this, okay? Now, what I'm going to put on this graph is our X-intercepts. So we have one at negative 2.58. And the other one is going to be at 0.58. Now, one really interesting thing about the our solution here, I'm just going to highlight it, is x is equal to negative 1 plus root 10 on 2 and take root 10 on 2. So if you want to think about it, this negative 1 part is essentially a line, is the average of those two x-intercepts, and you add root 10 on 2 to make 0.58, and you take root 10 on 2 to make negative 2.58. So we've actually found what's known as the line of symmetry here. We can say that this is our line of symmetry. X, LOS, is equal to negative 1. And that the distance here and here is both root 10 on 2. And that's why it's the line of symmetry. So if X is equal to negative 1 as the line of symmetry, we can now find our turning point. So to find our turning point, we're going to sub in negative 1 into our formula. I was going to square that. Okay, and we can see that it comes out as negative 5. So we've got our coordinate negative 1, negative 5. I'm going to put that point down here. And we also had a y-intercept at 0, negative 3, so we can put that there as well. We should have enough information now to help us sketch. So I may need to move that y-intercept a bit. And obviously this is like a little bit to scale. Let's move that. I'll draw this in first. There we go. So this is how we can sketch using our quadratic rule. So what's our takeaway? Well, how do we find that axis of symmetry, that line of symmetry? here's the key knowledge. This formula here, negative b on 2a, works out the line of symmetry. Okay, so that's how we can find our vertex really quickly. So I would love you to put that into your notes. The line of symmetry is equal to negative b on 2a. In this case, it came out as -1. Now with that in mind, have a go at the your turn on the right. Then, so pause the video and we'll go through the answers in a sec. Okay, we're going to go through the answers to this example here. So first thing, let's go across. We should have something like this. Using a quadratic rule. Okay, so here's our final answer in terms of the X-intercepts, and let's find out what those correspond to. Okay, I'm just going to double check my answers here. Yep, and we're just going to 2 decimal places for these. Yep. Okay, so we've got our X-intercepts there. The next thing is we can find our turning point quite quickly now, just using our line of symmetry. So, next thing, let's find our Y-intercept next. Nice and easy, that one. And then let's find our turning point. Now, turning point, X LOS is equal to negative b on 2a. Remember, that's our line of symmetry. And then we're going to sub into that rule. So our b in this case is going to be -6. Now what we could do is we could just get it straight from here, but I just wanted to show you how you can just get the line of symmetry straight up by using that rule. So we've got a line of symmetry here. We're going to plug that x is equal to 1 into our original rule, and that's going to find our turning point. So we've got 3 take 6 is -3 plus 1 is -2. There's our turning point. Okay, now I've got enough to graph on. We'll draw out our sketch. Line of symmetry is at +1. Okay. And then we've got our intercepts, 0.18 and 1.82. We've got our turning point at 1, -2. And we have a y-intercept at 0, 1. What we're going to do is just basically sketch a line out of this. There we go. And yeah, that's probably a bit pointy. You probably want to round that off a little bit more, like something like that, just to fix it up. But overall, that's how we do those kinds of questions. Hopefully you found this video useful. In the next video, we're going to be looking at discriminants, a little bit more into discriminants and how to sketch using those. Thanks.